So we will continue our discussion on coordinate geometry. Okay, so we have covered distance formula, section formula, midpoint formula, right? Then we have talked about area of triangle, and for that matter we have discussed about area of any polygon, right? And then we have discussed about collinearity, and we have seen a few questions which are related to distance formula, then section formula. We have seen section formula when internal division happen, when external division happen. Okay, then we have solved questions related to area of triangle. We have solved a question related to area of pentagon, and we have seen a question which is again related to the collinearity, right? So we were talking about triangle or 3 points, and they said that 3 points are collinear, and they have also mentioned all the vertices except one. Okay, one was missing, and we substituted that area is equal to 0, and then we got that point as 3 in the previous session. Okay, so in this session what we are going to discuss is, we are going to discuss about various centers of a triangle. Okay, so we will talk about the triangle again. So you will see the various centers. So first point that we need to discuss is about centroid. Okay, I'll tell you what is centroid, and we will see the equation. This is direct and straightforward. Then we will have to see what is incenter. So when we discuss about incenter, obviously we will also talk about excenter, and after that we have to talk about orthocenter. Okay, then we will talk about circumcenter. Okay, so circumcenter. So when we talk about incenter, you might have seen Inradius and Incircle. When we talk about circumcenter, you might have seen circumcircle, circumradius, etc. So this is the Inradius, which is touching the circle, which is touching all the 3 sides of the triangle. In fact, 3 sides of the triangles are acting as tangents to the circle. Okay, so that is what incenter. So we will talk about Incircle, we will talk about Inradius, we will talk about these 3 sides being tangent to the circle. When we talk about circumcenter, this is nothing but circle which is touching all the vertices of the triangle. Okay, so you will have to talk about circumcircle, we will talk about circumradius also. Then when we talk about excenter also, there is something called as Excircle. Okay, we will see that X radius, X circle, etc. So we will try to understand different centers completely with this session. Now let me start off with centroid, which is the most easiest one. Okay, so we will not be interested in solving to get the x coordinate and y coordinate, rather I will be giving it directly. Okay, so what is centroid? Let me take the triangle again. Okay, so what is centroid? If you ask me, centroid is nothing but the point of intersection of 3 medians from the vertex. Okay, so 3 medians from the vertex means one is this. Okay, what is median? Median will divide this 2 equally. One side, that side that you are taking, so if you are dropping median from this vertex, this will be dividing equally. That side will be divided equally. So this point is actually a midpoint. Okay, so this points, based on that also you'll get question. See, let's suppose this is x1, y1, this is A, and this is x2, y2, this is B, and this is C, which is x3, y3. Okay, so if I talk about median, okay, from B, dropped from the vertex B. Okay, so this is a median. Let me write it as D. Okay, so or let me write it as E. Okay, so this is D. So when I say this AD median, this line is dividing BC, okay, equally. That means this is a midpoint of B and C. You know how to find this point. If you know this and you know this, you can find this point by using midpoint formula. Based on that also you'll get very level 1 questions. Okay, elementary level questions. Okay, we are not interested in that. Now when you drop again median from here, this is actually dividing equally. So you can clearly see median divides the opposite side equally. Now the point of intersection of median is what we call a centroid. So here G is my centroid. Okay, so G is a centroid. What is G? G is nothing but the point of intersection of median. Median is what? Dropping from vertex and dividing the opposite side equally. Okay, or you can also say median is a line segment, okay, which is joining the vertex from the midpoint of the opposite side. Okay, so median is the line segment. There is a line segment which is joining the vertex from the midpoint of the opposite side. That's what median. So intersection of median is your centroid. Now there is no need to have any doubt. One more important point that you need to understand is this centroid divide the median in the ratio 2:1. So this will be 2 and this will be 1. This longer side is 2 and this will be 1. So this will be 2 and this will be 1. This will be 2 and this will be 1. Okay. So centroid divide the median in the ratio 2:1. Where is 2? 2 from the vertex. Okay. So you are dropping from vertex, then on the vertex side it is 2 and this side it is 1. So median divide the opposite side in equal. Okay, so median is actually midpoint, so dividing equally, and centroid divide the median in the ratio 2:1. This is the two key takeaways from this. Now, equation of this centroid, okay, or the coordinates of the centroid, if it is x and y, so g of xy is nothing but, this is very easy, right? x1 plus x2 plus x3 divided by 3, that is the x coordinate. Okay, similarly y1 plus y2 plus y3 divided by 3, that is your y coordinate. Now how you are getting this, if you ask me, that is not that important, but still, see, let's take this one median, let's take AD. Okay, so let me draw it like this, AD. Okay, so this is your AD. Okay, now G is your centroid, so G I'll be marking here, and we need to find the coordinates of G, that is xy. So A we know x1, y1. Okay, and D, what is D? D is what we are supposed to find out, but we can find out D, right? Because this is the midpoint. Okay, so we can get D anyway. Okay, so that is x2 plus x3 by 3, x2 plus x3 by 2, midpoint, and y2 plus y3 by 2. Okay, so you got this. Now we also know one thing, that this centroid divide the median in the ratio 2:1. Now you know the coordinates of A, you know the coordinates of D. Okay, now you know the ratio in which the centroid divide the line segment AD. So you can apply section formula and you will straight away get this. You'll get the x coordinate and you'll get the y coordinate. Okay, and you are getting in terms of x1, x2, x3, because x1 is here, x2 and x3 is here. Similarly y1 is here, y1 and y2 and y3 is here. Okay, so you can solve it and you can get this. This part is not important, but for your understanding. So two key takeaways. See, this is dividing equally. So when you're dividing equally, once you know these two coordinates, you can get this point. That's how we got this D. After that, we know the centroid divide the median in the ratio 2:1. So then we know this, and we know the ratio. So you can apply the section formula and get the answer. Okay. Now next is Incenter. So very important, guys. Centroid was very easy. Now Incenter, some of you might have confusion between all these centers. So let me explain it here. See, I am dropping one line. This is an angle bisector of A. Okay, so this is my A, x1, y1. This is B, that is x2, y2, and this is C, that is x3, y3. Okay, so clearly this is an angle bisector. I don't know it is whether it is going to pass through midpoint or any other point. It will definitely pass through this, but I don't know in which point it is passing through. Okay, obviously there will be some ratio, but I'm not sure about it. Okay, so this is my angle bisector of A. Similarly, that means what? This angle is divided equally. Okay, similarly I have another angle bisector here, B. So this is dividing equally. So these two angles are equal. Similarly, I'll be taking other angle bisector, okay, dividing angle C. So you can see this is dividing equally. Okay, so this is a meeting point of what? This is a meeting point of three angle bisectors, three internal angle bisector. I'm only talking here, you can see only internal angles. External angle concept I'll have to discuss when we discuss about Excenter. That's why I just mentioned about internal angles. Otherwise, if I simply tell you angle bisectors, then also the point is very clear to you, right? Three angle bisectors, A, B, C, dividing the angles equally. Obviously you can see that here. Meeting point is this. So what is Incenter? This is the Incenter. Incenter, I am marking it as I. Incenter I, which is nothing but the intersection of three internal angle bisectors. Okay, so firstly you can understand Incenter in that way, internal angle bisectors. Secondly, you can understand in another way also, Incenter is the center of a circle, okay, which is touching all the three sides of the triangle. So if you make a circle which is touching all the three sides of the triangle, the center is what is your Incenter. So that is actually formed with the help of three angle bisectors. Okay, so you can see AC is the tangent to the circle, AB is the tangent to the circle, BC is also tangent to the circle. Okay, so the three triangles, the three sides of the triangles are acting as a tangents to the circle, and that circle, if you take the center of the circle, that is what your Incenter. Okay, so this circle is known as Incircle, and this radius is known as this much is known as Inradius. Okay, now very important point that I need to discuss is, let me mark this side as D, E, F. Okay, so that means you are just extending this, and this is your D, E, F. Okay, now we know the sides opposite to this C, that is your C. Okay, so this is your C, and opposite to B, that is your B. Opposite to A, this is your A. So what is the CBA? These are my length. Okay, the three sides having length CBA, and angles again ABC. Okay, now here one important ratio. You take this angle bisector. This angle bisector from A, which is going to the opposite side of A, right? So this angle bisector which is coming from A, divide the opposite side. Opposite side is BC, right? So BC is divided in the ratio of the remaining sides. That means BD is to DC equal to remaining sides. Okay, so this side is what divided. Remaining side is AB and AC. So BD is close to this side AB. So I can write AB is to AC. We know AB is to AC means C is to B. So this will be in the ratio. This will be in the ratio C is to B. I hope you understood this. BD and DC, the angle bisector which divided the other side in this ratio, the ratio of the remaining sides. Same way, if you take this, okay, CE, this CE, okay, and is to EA, what it will be? This ratio CB and the other side, right, this AB. So that will be CB is to AB, which is equal to A is to C. Similarly, if you take this, okay, that is your BF. BF is to AF is equal to, so I'm talking about this one, right, BF and AF. So BF, the remaining sides means this and this. So BF close to BC, so I'll write BC is to this side, that is AC, which is equal to A is to B. This is a very important result that you can keep in mind. Okay, so in the previous case we have seen when you're dropping the median, median is dividing the side equally. But here the side is divided in the ratio of the remaining sides. That's it. Okay, very easy. So if you are taking this this angle bisector from A, I have BD is to DC. Actually my BC is divided into two, BD and DC. The ratio will be of the remaining side. BD is close to this C is to DC is close to this B. That's it. No need to have any confusion. Then when we discussed about centroid, I told you centroid divide the median in the ratio 2:1. So here we need to see the incenter divide the angle bisector in what ratio. So this is the incenter. Incenter is going to divide the angle bisector in what ratio. So let's take the first angle bisector. So you can see here AI is to ID, right? AI is to ID is divided in this ratio. See, this is dropped to this side, which is A. Okay, take the other two side and add, that is B plus C is to A. Okay, so I hope you understood. This AI will be like this, these two together, and ID is the opposite side. Similarly, if you take this, if you take BI is to IE, what it will be? You take the other two sides, that is the C and this A, right? So you'll have A plus C is to, on which side this was dropped, that is B. Okay, similarly if you take this CI and IF, so CI is to IF, which will be in what ratio? Opposite sides you take A and B, right? So that is A plus B is to C. So here it was A plus C, right? BI, IE, that is A plus C. Okay, so you can clearly see here, see ID is reaching A. So ID will correspond to A. See, IF is reaching C. So IF will be C. You can see IE is reaching B. So IE will be B. And the other side will be addition of remaining sides. Okay. So AI you can see here coming from A. So these two sides you need to add. I hope you understood. Okay. So these are basics that we have learned when it comes to Incenter. One important thing, that is the coordinates, right? We need to know that ultimately this is what we need to discuss. So obviously you are going to derive that from here only, okay, because you can get this D. You can get this D by using this points, and once you got D, see D you can get by using this information, the first information. Once you got D, you can get this ratio by using this information. Once you got this AD like this, A and D, and you know this ratio, you can apply section formula and you can get it. And finally you will get x is equal to, I just told you how you're getting it. Okay, now I don't want to explain it completely because that is not at all required for your exam. So x is equal to ax1 plus bx2 plus cx3 divided by a plus b plus c. All these are known, you know the three coordinates. Okay, so three vertices are given, so three coordinates are also given. So x1, x2, x3 you know. A, b, c are nothing but the sides which you also know. Okay, so you got x, y is equal to ay1 plus by2 plus cy3 divided by a plus b plus c. So this is your coordinates of the Incenter. So I hope you understood about Centroid and Incenter completely. Okay, now next we need to move on to Excenter. That is slightly difficult in understanding because we have not dealt with Excenters often, right? We get questions related to Centroid, okay, maximum, Orthocenter, Circumcenter, Incenter. We have not seen questions related to Excenter, but just for the purpose of discussing this point, I need to discuss it. Okay, see what is Excenter. You take this is again related to angle bisector, but as the name suggests or the name indicate, this is going to tell you something related to external angle. Okay, so let me draw the same triangle. You have a triangle A, you have B, you have C here. Okay, now what you can do is you can produce this A like this and you can produce this AB like this, so it will go like this, and you can produce this AC like this. Okay, now so I hope you understood. You had this triangle, you know x1 y1, you know x2 y2, you know x3 y3, that is coordinates of A, B, C, right? You produced AB, you produced AC. Now you drop the internal angle bisector of A like this. So this is the internal angle bisector. Now from B, what is internal angle bisector? This is internal angle bisector, and C, this is internal angle bisector. So this is your Incenter. No confusion. But what I'm saying is now from B, drop external angle bisector. How is it that going to happen? Like this. So this is your external angle bisector. From C, drop external angle bisector. So where is it meeting? This is your meeting point, and that's your Excenter. So I can mark it as I1, okay, or E1 Excenter. Okay, so I hope you understood what is Excenter. So Excenter is basically the meeting point of internal angle bisector, one internal angle bisector, okay, and two external angle bisector. So this Excenter will be the opposite of the internal angle bisector. So I am dropping internal angle bisector from A, so I am getting the Excenter opposite to A. Similarly, if you have this triangle and A, B, C, if you would have produced this side like this and this side like this, okay, that means now I am going to drop internal angle bisector of C. So what you'll be getting? You'll be getting Excenter on this side. Similarly, you can get this. So corresponding to each vertex, corresponding to A, this angle bisector, you have an Excenter. For C, okay, for C you will have an Excenter here, okay. For B also you'll have an Excenter here. So unlike Centroid and Incenter, there are three Excenters. So three Excenters which are corresponding to A, B and C, three vertices. Okay. Now one more understanding, that is this Excenter is the center of a circle which I can draw like this. Circle which is touching this side of the triangle, and this being the radius, and we call this circle as x radius, and this circle as x circle, and this radius is x radius, and this is also touching the produced side of other two. Okay, so Excenter is touching the opposite side of angle A, because the Excenter is formed opposite to angle A, so it is touching the opposite side of angle A and also touching the produced side, other sides. Okay, so this side and this side. So here also you will see, if you extend this, okay, so this circle is going to touch like this, and you will get like this also. Okay, you can produce it and you can get a circle which is touching like this. So you'll get 3x center, 3x circle, 3x radius. I hope you understood. Okay, so Excenter means drop the internal angle bisector, then two external angle bisector. The intersection of two external angle bisector and internal angle bisector is your Excenter. Okay, so opposite to each internal angle bisector you will get one Excenter. So there are three Excenters. Now what is the equation? So now we need to know the equation, right? We need to know the coordinates. So we have three Excenters, E1, E2, E3. So there is one small change that you need to make in the equation of Incenter. That is, see, if I write Incenter, what is that? X coordinate will be A1, ax1, okay, ax1 plus bx2 plus cx3, three sides divided by a plus b plus c, right? Comma, what about y coordinate? ay1 plus by2 plus cy3 divided by a plus b plus c, right? So what we need to do here is Excenter 1, if this is opposite to a, make a negative, put a negative. This is ay1, okay? So put a negative. So in the equation of Incenter, put a negative, what you are getting is Excenter opposite to a. Similarly, E2, that is Excenter opposite to b. What you need to do? You make b negative. So that is going to be ax1 minus bx2 plus cx3 divided by a minus b plus c. You can clearly see minuses for b because we are finding the Excenter which is opposite to b. Similarly, y coordinate ay1, a become positive now, b will become minus by2 plus cy3 divided by a minus b plus c. Okay. Similarly, E3, Excenter 3, that is going to be ax1 plus bx2 minus cx3 because this is opposite to c, okay, divided by a plus b minus c, comma, ay1 plus by2 minus cy3 divided by a plus b minus c. So I hope you understood this. These are the three Excenters that you get. So see, Incenter is one only, Centroid is one only, but there are three Excenters. Now Incenter is inside the circle, Centroid is inside the circle, Excenter is always outside the circle. So Incenter also we have seen a circle, okay, now, okay, see, what is Centroid? From vertex dropping the median, okay, so intersection of median is the Centroid. So this two will be equal, this will be equal, this will be equal, okay, so opposite side divided equally. When it comes to angle bisector, this angles divided equally, right? This angles divided equally, and sides ratio we already understood, okay? So this is your Incenter, this is your Centroid G, this is your Incenter I, and with respect to Incenter I told you, you can get an Incircle with this as the radius, okay? So this is the radius. Now can you find the radius? Obviously, because you know this point, you know how to find this point, you already got it, you know this point and you know this point, so you can find this midpoint also. Not midpoint, if the ratio is given you can find this point, it's not midpoint. If ratio is given you can find this, so this is your radius, okay? So you can find Inradius. So this is tangents, these three sides are tangents, so Incircle, Inradius, okay, that is one way of understanding Incenter. Other way is intersection of three angle bisector, internal angle bisector. Then we have understood produce this side A, AB you produce, AC you produce, drop an internal angle bisector, drop external angle bisectors, meeting point will give you Excenter. You can obviously draw the X circle which is touching the opposite side of A and the produced side of AB and AC. And this radius is known as X radius. The circle is known as X circle. There will be three X circles for a triangle. That means there will be three X radius and there will be three Excenters. And we have seen three Excenters are E1, E2, E3 like this. So Centroid coordinates x1 plus x2 plus x3 by 3, then y1 plus y2 plus y3 by 3, okay. Then we have seen the coordinates of Incenter, ax1 plus by1. So when you talk about x coordinates, only x will come, okay. So ax1 plus bx1, bx2 plus cx3, okay, divided by a plus b plus c. Then ay1 plus by2 plus cy3 divided by a plus b plus c. That is Incenter. When it comes to Excenter, corresponding to a, in the equation of Incenter, you change minus. Okay, a should be minus. So minus a x1 plus bx2 plus cx3 divided by minus a plus b plus c. Same as the case with y coordinate. If it is opposite to b, change b as minus in the equation of Incenter itself. So if you know Incenter equation, you know Excenter automatically. Okay, just that you need to change that minus symbol corresponding to the opposite angle. If it is opposite to a, change a minus. Opposite to b, change b minus. Opposite to c, change c minus. That's it. Okay.